Ladies and gentlemen, good morning. So welcome to the summer semester, also from my side. We already met, but now officially welcome to this part of your semester this year, this Rural Urban Transformation study project. This semester we will, or I will concentrate on teaching the applied system dynamics for urban modeling and simulation to you. I think most of you have been in the seminar last semester already, so you are well prepared. Okay, so you may remember there is this documentation script where I've also described what to do. So we start with this C# script component. You can either, if you want to make a new one, you just need to write C or double click on the canvas, write C#, and then you can create a new component for entering your C# code into it. You can also find it under math, and there you have this C# script. There's also Python and Visual Basic, which is more or less, or offers you very similar or the same possibilities, just with other programming languages or scripting languages. Okay, C#. If you zoom in into this component, you see these plus and minus icons. That's especially important for registering new inputs and outputs. So if you press a plus, then it adds a new input parameter, which you can use in your script. The same for the output. If you want to register a new output parameter, just press plus, and if you want to put it away, minus. You can also rename these parameters and give it a custom name. Then it's as an you just rename it, and that's important for if you open the script now, you will find in the header, in the run script part, the names of your input parameters. So custom, that's what I've changed right now. And Y and Z, that's what's already there. And the A parameter you also see here as this ref object A. That's what you can return from the component. That's the output parameter. When you change one of these parameters, so Y2 for example, it's not directly updated here, because when you open this window and change something somewhere else, this doesn't update automatically, so you have to close it, usually by pressing OK. And, oh, what's wrong here? Open it again, and after opening it again, you see there is this Y2 input parameter now. The type, so the type of the parameter predefined is an object, so that's a very general type. So you can change it by pressing the right mouse button on the parameter and go to this type hint. And here you see you can define what kind of parameter you want to read. So it may be a geometry type, like a point, a plane, a line, a circle, or these basic types like an integer number or a double value, so a floating point, or something else. So here you can change these things. And if you say, okay, it should be an integer, an int, then you have changed it, but again, you don't see anything here. You have to close it and open it again. And then you see now my y2 parameter is an integer parameter. Okay. So probably we'll come back to these things later, but that you just have an idea why or how to change input and output parameters. That's done not in the code itself. So these gray parts of your scripting window you cannot change. You can only change the white part. Gray things need to be changed from the outside. Good. Okay, so now starting with the most exciting part you can do in scripting, writing a string and outputting it to some output window. And usually in every programming tutorial, you start with this hello world string. This gives you an idea about this basic concept of declaring a variable and assigning a value to a variable, changing the value, and sending it to an output. That's done in these first 3 lines of code. So you see we have here again these x1 and y parameters, but we don't use them so far. x1. We just have these first 3 lines of code. Probably in your example files it may be green. If it's green, it means it's uncommented, it's deactivated. There are 2 ways of deactivating a code. The first is by writing 2 slashes in front of the line, then it becomes green and it's not executed by the compiler, so nothing happens. And if you delete the lines, the slashes, then it's activated again. If you have a bigger part of a code, then you can use this slash star until you write a star slash. So everything between is uncommented. Like I've done it here, slash star to star slash. That's then activated or deactivated. You may remember there are a few basic types that you can use for declaring a variable. Numbers or Boolean values saying true or false, or like we've done it here, a string that stores more or less a text. So we say we want to have a variable, my first string, it's the name of the variable, and to say what kind of variable it is, you use this keyword string. And keywords are then shown in blue. This means you cannot use this word for something else because it has a predefined meaning. You cannot say your variable should have the name string. This doesn't work because some words like string or double, they are reserved for or they have a special meaning for, in this case, C#. So every programming language has these reserved names that you cannot use for anything else. So you declare the variable, and at the same time you can say you want to assign a value to the variable, and this value in this case is a text. Text need to be written in this how are they called? What are Anführungszeichen? Quotation marks. Thank you very much. In the quotation marks. This means that's a text. Also, if you have numbers and want to store them as a text, if you put them in quotation marks, then it's a text, not a number. So the first part, if we uncomment this, is declaring a variable and assigning a value to the variable. That's more or less the most simple task that you can do with writing a program. That's declaring a variable and assigning a value to it. And then in order that we can see if if it has worked what we've done, there is this print command. So if you write print and something in the brackets, then it's sent to the out parameter of your component, which is always part of the script, of the C# script component, this out parameter. And always if you print something, it's automatically sent to the out output. Also, if there is a bug or something that doesn't work, if you have made something wrong, like forgetting this quotation mark, and if you run your script by pressing this run button at the top right side, you see this out is also used to show you what error you have in your code, and that's usually very helpful because it says error blah blah blah, and then it tells you what's wrong, in my case in German, and then it tells you the line, and that's the most important thing. So it tells you there is an error in line 70. Usually you also get, or often you get, important information what kind of error it is. Here you see it also by these red parts. Something is wrong here, and that's because I've forgotten this. And if everything's fine, the output is used to print what you sent by the print command. So these two lines, I hope it's clear. If you want to manipulate the value of a parameter, of a variable, you can do this, for example, like I've done it here. You can say your parameter, your variable should get a new value, and this is the value of the variable itself plus something. So with strings you can use this plus and minus, I don't know. At least you can add or put two strings together by using the plus, and what happens is you just add this part of a string 1, 2, 3 with this code. There is another way, more or less a shortcut, that you may see from time to time. If you don't want to repeat the name of the variable, you can just write it like this, and it doesn't work. Why not? So this is the same. So if you say variable equals to variable plus something, you can write it in short by saying variable plus equals to something. This means there will be something added to your variable. Now we want to do something much more spectacular. We want to create a line in Rhino. So if you uncomment this part and deactivate the part above, press the run button, don't find it. By the way, if you create some geometry with a component and you cannot find where it's drawn in Rhino, maybe like this, you can select the component and use the right mouse button or somewhere on the canvas and say zoom, and then it zooms what is created by a certain component. This works for all components. It's good to find the geometry, because sometimes you use a completely different coordinate system and then it's somewhere on the Rhino canvas. Okay, so now again the repetition for introducing or for using geometry types, basic geometry types. In this case we use a point 3D. That's from, I assume, from Rhino. This is again a keyword, but it's not in blue because it comes from a different library. So it's not the basic C# code, it's imported from another library, in this case from rhino.geometry. So these parts that are usually merged in the beginning, this using. This tells you which other libraries, which other namespaces you can use in your script. This is the predefined setup. You can also add here own libraries. I will show you later how to do this. But in this case, you see you can use, for example, the Rhino geometry namespace. This is a kind of a library with all the objects that you use in Rhino that has to do something with geometry. And you can call it from this library, use it in your code, and generate or create the geometry by sending it to the output of your component. If you want to know what's written in this library, you can just copy it. I think I have also provided you a link on Moodle to this. Somewhere else. So Rhino geometry. Here you see the namespace. That's a website where you have the documentation of all the Rhino geometry classes that you can use. So usually the more complex data types like a point 3D, that's a class. This can store a more complex data structure like coordinates of points, for example, which is basically 3 numbers. But that you don't have to store always 3 separate numbers like integer or double numbers for a point. There is the point 3D class that offers you to store these numbers in one data type, plus doing some other things for you, which is called the methods that are assigned to this class. But we will see this later. First of all, the interesting thing is how to declare the point. So that's very simple. You say you want to have a point 3D, and then you give it a name. So that's the name of your point 3D. I call it from point because I want to draw a line from a point to a point. So from PT, from point. And then you say you want to make a new, so usually if you have a class and you want to make a new instance of a class, you do this by using this keyword new. And you say you want to create a new instance of the class point 3D. And then you have these parameters. If you open the bracket, then you get this very small intelligence which tells you what is expected now. That's very helpful if you use a class that you're not familiar with. Then you have here 1 of 5 possibilities to create a new point 3D. This means this class has 5 constructors, how to create, how to construct an instance of the class. And the first one tells you you can send a double or 3 double values, x, y, z. So these are 3 numbers that defines the coordinate of a point. There is another way to create a point by using a vector 3D. A vector 3D is basically more or less the same as a point, but a little bit different. Or some other point structures, point 3D, point 4D. So in this case, it's very trivial. So we use this, the constructor with these 3 numbers, and then you just have to send 3 numbers. In this case, you can use double values, so floating point numbers, to declare the point. So you see, I use 0, x1 and 0. x1 is my input parameter. That comes from the input to my component.
Was it possible that you had the possibilities of what to choose next to the point? Because you could see that there are 5 different possibilities of how to create a new point.
How I've seen this?
Yeah.
So the question was how to show this IntelliSense support if you write new point, so the name of the class, and in this case then open this bracket, then it's shown automatically. You don't have to do anything else. This doesn't work always. Sometimes, for some reason that I don't know, it doesn't show up, but usually it works. So usually, probably if you reopen it, it works again. I don't know why. Sometimes there is an issue. Okay, so 3 values assigned to the constructor of this class, and then you have a new point. So you can assign numbers directly or other variables. So that's now the first step where programming becomes interesting, that you can create some new classes, some new objects by using parameters or classes from others. That's in the end more or less the same what you do if you use the components and set the wires between the components. So here we just do it in text form. If you use Grasshopper with the predefined components and link them, then you do it in a visual way. That's why it's called visual programming, and here we do it by using text. So the same thing we do for the other point. We create a new point, which we called 2pt, which I use as the destination for my line. Here I use again x1 for the x coordinate, y also coming from the input as the y coordinate, and 0 for the z coordinate. If you want to create now a line, we use this Rhino geometry.line. That's the namespace. Probably we don't need this part, I assume. Right. So I've just added it to tell you where to find these objects. You can either use line if you're fully aware from where it comes, or you say, I want to use something that's in the rhino.geometry namespace. And if you press now the button, if you write rhino.geometry dot, and then you get again this wonderful intelligence support that shows you which objects are in the library of rhino.geometry. So that's what I've shown you on the website. So on this website here, all the classes in rhino.geometry. You see them here as well. They are all listed here.
What was the name of the website?
Of what?
The name of the website?
The name of the website. If you put Rhino separate geometry into your search engine, then you will end up at developer.rhino3d.com. I think it's also added in here in the Moodle page. There is a link, an overview to the classes and objects you can use from Rhino. So you can write it either like this. You can also, that's the same for the point 3D. This works as well, that's the same. Usually you don't need to write the full path of the namespace as long as you don't have two libraries with the same classes that have the same name. Then there is a conflict, then your compiler doesn't know which you mean. Then you have to write the full path. But if you have only a library, only one library that contains a point 3D, then it's fine. You don't need to do anything else than to write the name of the object of the class. Anyway, so you want to say you want to create a new line. Then you give it a name, and again you say you want to create a new instance by using the keyword new line. And once again, if you write this, if you make this bracket, you say you see there are 4 options to create a line. The first one is the one that we use. You need the point 3D from and the point 3D to the 2 points that you want to connect by a line. You can also use a vector or the start point, the direction and the length, and so on and so on. And finally, I send it to the output A. So that's here A. A takes more or less everything. Object is something like the mother of all other classes. So everything that you use is some kind of object, nearly everything. So this is done by just saying A equals to my line. My line is the line that I created in before. And if you do this, it sends it to the output. And if you move with your mouse above the A output, you can also see that it writes one locally defined value. So it's a line with the length 12. This is also shown if you link this to your output line with the length 12. You remember we've used, by the way, that's a bit strange with using this scripting window. At the moment when you click somewhere else, it minimizes the size of the window. That's so far okay, but if you double click on the editor again, it opens a new window. And if you make some changes now, saying deactivating the output, press OK, then the line disappears because I've changed my code, but there is this window open. And if I say do what's written here, then it uses the old code. So if you have 2 windows open, or 3 or 5, because you're a little bit confused and open it again and again, change in every window something, then it becomes a complete mess. So be aware that you should have only one of these windows open for one script component. Otherwise you overwrite parts of your code. That's really dangerous. At least it happened to me. And I wondered what happens. And if you want to store it, you can just close it by pressing OK. And only at the moment when you press save the current file of your Grasshopper file, then also the content of your script is stored. Only if you press this save button, it's stored. OK. If we close it, no. I wanted to point you to the fact that I've used here these parameters because we are doing parametric modeling in the end. So the X input is used for the Y coordinate of my from point and for the X coordinate of my to point. This means if I change it, my line will do something like this. So it's changing the X and the Y coordinate, plus it's also used for the, I know, that's the only thing that's changed. So you are familiar with these sliders from Malik's course last week. So here you can control your own line and use your own parameters. Now, what happens if I change the parameter name here? If I press the right mouse button on the parameter and say now I want to rename it because I don't like that it's called x1, I want to have it x, then surprisingly it's still working. That's interesting. Okay, now this should happen. You get an error message. So here you have these nice error messages. The name x1 is not available in the current context, line 76 and 77. So let's look into line 76 and 77. So there I use x1, and this is not available because I renamed it to x. So what to do to solve this problem? You just rename this parameter as well, and everything is fine again. So just take care, if you change these input names, you have to change the code as well if you have used this input name already in your code. So what you can do is you can play around. You can also say this is always x multiplied by 2 or whatever you want to do. Then it changes the coordinate. So it's very trivial. But you can already play around with these parameters just to understand the effect of this simple input and output. Then it's speeding up this rotation movement. So the mathematical operations, I think I hope you can remember. So so to multiply it, it's using the star. That's multiply with something. If you want to divide it, it's the slash. Otherwise minus and plus, that's trivial. What else is? I think these are the most important operators that you can use. And to make the code active, you have to press the play button. So it only executes it, makes it active if you press this play button, or if you say you want to close the window by pressing OK. I think it's not a good idea to close it. Let's try what happens if you close it by closing the window. Yeah, so if you close the window without either pressing play or OK, it just deletes your changes. It's also dangerous to lose some code. If you change something, write new code for 1 hour and then press the red cross, then it's gone. Great. So from time to time, save what you do. Otherwise, you will be very angry. Okay. So rotating, moving line. So far we use this Y input, but we don't change it. You can either change it by connecting a new slider or by right-click on the parameter input and go to set data item. There is a value. At the moment it's 12. If you change it to 15, commit the change, then you see your number has changed. Or if you make a new slider, the short version of creating a new slider is double-clicking on your canvas and entering a number, for example 12, and then it creates a new slider. Couple it, and here we can also manipulate the Y parameter. So the next step is to make even more complicated object a rectangle. If you deactivate this part again and uncomment the rectangle, so the last part of this script, and press play, you will see, oh, a surface appears. If you don't want to see the surface already, you can also deactivate the second A output and activate the first one, and you see only the rectangle without a surface, without the filling. So if we look into the code only until here, we create a rectangle. For creating a rectangle, that's again some object in the rhino.geometry namespace. Now it's a rectangle 3D. I give it a name, it's my rectangle, my rect. And with the new keyword, you create a new rectangle 3D, means it's located in the, oops. In the 3D, in the three-dimensional space. which means you have to define the plane on which you want to draw your rectangle first. Because since it's a rectangle 3D, you could theoretically place it everywhere in space, rotate it into a certain direction. So the first part that's needed is on which plane you want to draw your rectangle. Therefore, we have this predefined object, or the predefined value world x, y. So there is a collection of planes under the keyword plane. You see here. So if you say plane dot, and then you see what's in this collection of planes. There is also a world xy, a world yz, a world zx. So we use the word xy. You can also change it, and then you will see your rectangle in a different viewport. And what we need is the width and the length of our rectangle. And these values we have defined in before with our double width and double length. Double again is a floating point number, so you can also say 20.6. That's possible with a double value. That's not possible with an integer value. Integer only takes values without the floating point part. So the 10 could be also an integer. And then you send it to your output, and Rhino draws the rectangle for you. You can also replace these parameters again. If you say, okay, I want to use my slider input y, then we use the height parameter from here, and you can also control the rectangle that you created with the slider. So just for visualization purposes, since I don't see here, so it's only the outline of the rectangle, we can create a surface. For creating a surface, you have to convert your rectangle into first in a NURBS, because Rhino is a NURBS modeling software, and then you convert your NURBS curve into a surface. So a BREP, a boundary, a representation, so a surface represented by its boundary. First of all, we create a NURBS curve. That's not difficult, so you just have to say you need a NURBS curve because that's needed for creating the surface. You give it a new name and you say my rectangle shall be converted to a NURBS curve. So every rectangle can convert itself to a NURBS curve. In our case, we needed to create the surface. I mean, we could also skip this, but then it becomes more difficult to read the code if you don't want to say, I want to see this NURBS curve at all. You can place this conversion part directly into the parameter of the constructor. Then it would look like this. It's doing exactly the same. But in order to make it more readable, I've just done it explicitly that I first create here a variable NURBS curve, and just for the only purpose to put it into the constructor of this BREP, the boundary representation. That's all. If you want to make a surface, you usually have to create a BREP object in Rhino or C# code. Oops. Also here there are many ways to create this surface. In the end, that's always the same as you create the surface with the components in Grasshopper. Here you have this list of possibilities, what you can do, but if you know how to do it in Grasshopper, you shouldn't have a problem, at least with having an idea how to create it here. And finally, we send it to our output A. And then we have this filled rectangle. So the only idea is to get a filled rectangle. That's then the surface. Okay, so this was a little bit an extended explanation of this simple part of the code, but I mean, it's always good if you keep in mind that if you have some questions concerning some objects that you don't know what they should be, just go to this SDK documentation and put it in the search field and look for the object, and then you always get a short description at the beginning. So what a NURBS curve is in general. I don't know if you can do something with this explanation, but you get more detailed information on this site. Okay, so as mentioned in this PDF, in the script, there are also, I mean, many things I've explained to you. Some other parts you can read there, for example, about some other basic data types. You can find this information also in the internet on some web pages that introduces C# script or C# programming language. Here you can also find some explanation of the parts that we've done. You see here also how to deactivate the grid if you don't want to see the grid, or if you want to have a white background. That's described here. And also the examples until the creation of this rectangle is here.